Panel objects are used to implement both web applications generated in Angular and applications generated for mobile devices in Android or iOS. That's why the events available in this object are mostly valid for both platforms. In this video, everything about events in a panel object will be applicable to both types of platforms. Exceptions will be explicitly made where appropriate. As we already know, events are messages displayed by the software or the system at certain moments during the execution of an application. This allows us to schedule actions to be executed at those moments. For example, if the user clicks on a button, or types something into text control and exits, or if the server is required to send updated information, we can schedule a response after the event is triggered. Suppose that when viewing data about attractions, we would like to have filters so that the data displayed meets the selected constraint. To implement this, we open the View Attractions panel and save it with the name View Attractions by Country. Now we go to the Variables section and add a variable, Country ID, that automatically takes the type of the Country ID attribute. We drag it to the form after the text box of the title, and in its properties, we change the Country ID label to Country. Next, we change the control type property to Dynamic Combo and set item descriptions to country name. In addition, we set the empty item property to true so that at the beginning, the combo appears without any default value. For the filter to have an effect on the attractions that we see in the grid, we edit the grid properties, and in the conditions property, we write country ID equals country ID, the variable, when not country ID dot is empty, and close with a semicolon. Now that we're in the grid properties, we set the auto grow property to true so that the grid auto adjusts to show all the records. Once we choose a country, the panel must be refreshed so that the grid loads only the attractions from that country. For this, we use the control value changed event of the Dynamic Combo. So, we go to the Events tab, and in the menu, we choose Insert Event. We click on Country ID and select the event we mentioned. As we can see, the event code opens for us to write what we want to have executed when this event is fired. We type refresh. This command will cause the grid to get the data again, filtered this time by the chosen country. For the server to understand that we want to bring new data, the URL sent to the server must be changed, so that the server interprets that it's a new page and obtains the corresponding information to send it to the client. To this end, we add a parm rule with the variables that we use in the filters, so that when they change their value, the page is updated. In this case, we add only the variable country ID. We right-click on the View Attractions by Country panel and choose Run. Since we had set the empty item property to true, the combo is displayed without a selected country, and all the attractions are shown. If we choose China, we see that the grid is reloaded, and now shows only the tourist attractions of China. Let's take a closer look at the events. In a panel object, we have two types of events: events that are fired on the client side and events that are fired on the server. The server events are the same as when we work with web panels: the start, refresh, and load events. These events will always be fired on the server in the case of Angular applications and native online mobile applications. In the event we're deploying offline native mobile apps, they'll be fired internally on the device. The events on the client side are client start, back, user-defined events, events associated with screen controls, and also the events predefined by the work with pattern, which is a pattern that, when applied, allows generating a series of panels that fulfill the functionality of working with an entity to perform insertions, modifications, deletions, data navigation, filters, and so on, analogous to the work with pattern that we use when working with web panels. In the event that we use the panel objects to generate an application for mobile devices, we'll have the events associated with the navigation styles of the information, which depend, for example, on the type of device and its orientation when the application starts. Now let's see the server-side events. The first one executed is the start event. It's executed only once when the panel is opened, and will not be executed again unless we exit the object and reopen it. The refresh event is executed after the start event, usually only once, but it can be invoked again using the refresh command. In that case, it'll be executed more than once and will be the first event, since start will not be executed again. When the refresh event is invoked, the load event will be triggered at the end. This will only happen if there's at least one grid in the panel and the grid is not a collection SDT variable. The load event is the last one of the system events to be executed. If it has a base table, it'll be executed as many times as records exist in the base table. If the grid doesn't have a base table, it'll be executed only once. And if the grid is based on an SDT, the load event will not be executed. In the case of an application for mobile devices, the code of the start, refresh, and load events has no access to the device's resources, such as camera, GPS, and so on. Let's consider the case of the following panel, which allows viewing a grid of attractions and filtering the grid by country and attraction name. The panel View Attractions by Country, which we saw recently, will save with the name View Attractions More Info. We'll add variables to it to filter by name of the attraction, and also a pair of variables to count the total trips. The grid contains the attributes attraction ID, attraction name, attraction photo, city name, country name, and a trips variable that'll show the trips made to each attraction. Below the grid, we can see the overall total number of trips made to all attractions. We can also see the model of the transactions used in this panel, and the grid conditions that allow performing the filters. Refresh and load events that are triggered on the server side are programmed in the Events tab. In the load event, we calculate the total trips of an attraction by means of a formula that accesses the trip attraction table, corresponding to the second level of the trip attraction. Note that in the count formula, we're referring to the trip date attribute, and due to the attributes present in the grid, the base table of the grid, that is, of the variable part of the panel, will be trip attraction, so the trips corresponding to each attraction will be counted. In the refresh event, we program a for each to access the trip attraction table to count the overall total number of trips of the attractions. As a result, when the fixed part is drawn, the data corresponding to the total number of trips is already available. If we look at the application running in the browser, we see that the total number of trips of each attraction is displayed correctly, but the overall total number of trips comes out at 0. What did we do wrong? The total trips variable is being increased in the load event as we did in the web panel, and we're sure that this event is being triggered because we see that some attractions have trips. So, the reason is that panel objects don't work in the same way as web panels. In panel objects, the fixed part is loaded independently of the grid. In this case, the total trips variable is in the fixed part of the panel, which is the first thing to be loaded. Then the grid is loaded, so when the variable is displayed, the grid has not been loaded, the load event has not been triggered, and the value of total trips has not been added yet. Remember that in a panel object used to develop customer-facing applications, to load the screen in the client device, services located in the server are invoked, which are the ones that access the database. These services are data providers, which are independent for the fixed part and for the grid, or each grid of the screen. When the panel starts running, a local event is triggered on the client that invokes the data provider to load the fixed part and causes the start and refresh events to be triggered on the server. Then, a second data provider is executed which triggers the load event on the server n times, and the grid is loaded. In our example, as the refresh is triggered first, the total trips variable is initialized, and the fixed part is loaded. Later, the load event is triggered, which is where total trips is loaded with the correct value, and the grid is updated, but the fixed part was already loaded before and is not redrawn. Due to this feature, we cannot program the panel object as if it were a web panel. In another video, we'll have a closer look at the triggering of events and the determination of base tables. For now, to make the example work, we'll change the programming. The solution is to include in the refresh event a for-each command that accesses the trip attraction table and counts the overall total number of trips. Let's not forget to remove the calculation we had in the load event. The reason why we include the update in the refresh event using a for-each command is because the refresh event will be triggered when the fixed part is loaded, which will be before the grid is loaded. Therefore, when loading the fixed part, the value of total trips will have the correct value, and only after that, the grid will be updated. Now let's take a look at client-side events. These events are the application's response to user interaction. There are several types of client events. System events such as client start and back, user events, on-screen control events, and others that we'll see next. The code associated with these events is executed in the client, unless access to a server resource is requested. For example, if you want to access the database. In this case, the client will have to invoke a server service. During the execution of a client-side event, server-side events are not executed unless explicitly requested through the refresh command. This causes the server's refresh event to be triggered, followed by the load event, if there's at least one grid, as we saw before. When running a native application for mobile devices, client-side events have access to all hardware and software resources of the device, such as camera, GPS, microphone, calendar, contacts, and so on. These client-side events will have a specific grammar that's different from that of server-side events. Let's take a brief look at each client-side event. The client start event is the first event to be triggered, even before the start event that's triggered on the server, and with no need for any user interaction with the application. It's used to initialize the home screen and UI-related aspects. The back event is used on mobile platforms and allows you to capture that the user has pressed the back button on Android devices, or that the back gesture was made on iOS devices and programs an appropriate action. User events have a name given by the user and allow the developer to associate a certain code to be executed when a certain on-screen control is activated by clicking or tapping on it. On-screen controls have their own events, depending on the control involved, such as click or tap, double-click or double-tap, drag, swipe, control value changed, and so on. These events are triggered when some of the above actions take place, and the developer can program a response of the application to the user's interaction. The work with pattern has predefined events that are triggered depending on the action performed on the data of the entity to which the pattern is applied. These include the insert, update, delete, save, and cancel events, among others. The events available will depend on the part of the work with object being executed, list, detail, and so on. In the case of mobile devices, depending on the type of device and orientation, when we start the application, a start event will be triggered depending on the navigation. For example, if we're using a tablet, by default, the application starts in split mode, meaning that the screen is divided into two sections, with a list on the left and the detail of the selected item on the right. In this case, when the application starts, the split.start event is triggered. In the case of phones, for example, the screen will show only the list, and a separate screen will be opened to view the details. This mode is called flip, and is the default behavior in these devices. Therefore, when starting the application, the flip.start event will be triggered. Although there's a default navigation for each device, the main objects of mobile applications have a property that allows changing the way the application starts. These start events associated with the type of navigation are triggered at the start of the mobile application and immediately after the client start event. In the object we saw before, we program only events associated with controls. We don't program any user events. To each variable of the on-screen filters, we program its control value changed event to trigger the grid refresh method, which will cause the server refresh and load events to be triggered to update the contents of the grid with the filters entered. In short, let's see what can be done in a client-side event. We can invoke another panel object, we can invoke REST services, and when we invoke procedures or data providers, they'll automatically be exposed as REST services on the server. If those procedures or data providers were invoked only from a server-side event, within start, refresh, or load events, they would not be exposed as REST services because they would not be necessary. We can use business components to retrieve or update information. In this case, these business components will also be exposed as REST services automatically. It's possible to directly invoke any node of the work with pattern. In mobile applications, we can invoke a menu object. We can also invoke the external objects defined in the GeneXus module. Some of these APIs only make sense for a particular platform, such as mobile devices. Meanwhile, some of them can only be used on web applications, and others can be used on both platforms. To find out which ones can't be accessed by Angular applications, visit the wiki page shown on screen. We can also call subroutines, and in addition, we can assign properties to controls, assign simple or STT variables, run for each line and for each selected line on grids, use the blocks if-else, do-case, and do-while. If we try to use commands not allowed in a client-side event, we'll see an error in the output screen for those lines that don't comply with the grammar constraints. For example, if we try to use a for each command, a new or any attempt to access or modify information that's only accessed from the server. Here's a summary of the commands we can use in the client-side event code. These restrictions are only for client-side events, but not for server-side events. Start, refresh, and load, where we can use all commands and functions available in GeneXus. As for commands, the accepted ones are shown here. Now let's look at the composite command mentioned above. This command is used in panel objects on client-side events. This command is important because if an error occurs in the call sequence, it stops running, and the errors are automatically handled and displayed on the screen with no need to implement any programming. This is a big difference with web panels, because when a called object in an event causes an error, the execution is not interrupted. It continues in the following statement, and the developer is responsible for handling the errors and programming the actions to be taken. This composite command is optional. If we don't use it, its functionality will be identical to web panels. Now let's see what happens with events when we run a panel object. The client start event is executed first, and it's executed only once on the client. In mobile applications, the start event corresponding to the type of navigation set in the main object is then triggered by means of the navigation start property. Next, a data provider is executed that will return the data needed to load the fixed part of the panel. This data provider is involved in the execution of the code of the start and refresh events to be executed on the server and returns, in a single result, the information to load the fixed part. The fixed part of the panel is drawn later. Then, a second data provider is executed that will retrieve the data required by the grid. Within the execution of this data provider, the load event code is executed on the server. This load event will be executed n times when the grid has a base table, once for each record, only once if the grid doesn't have a base table, and not at all if the grid was from a collection SDT variable. At the end of the execution of the data provider, it'll return the information generated by all these executions of the load event in a single result, which will be used to load the grid, and then finish drawing the grid. We've mentioned that the fixed part of the panel is loaded independently from the loading of the grid. Different data providers are invoked that are published on the server as services, and access the database to retrieve the information of each part. When we change the value of a filter, the grid's information needs to be refreshed. For this, we need to add the grid's refresh method, which will trigger the server's refresh and load events. In turn, it'll cause the grid to be reloaded, applying the programmed conditions and displaying the filtered results as expected. Since the grid's refresh command must be invoked after we change the value of the filter variable, we use the control value changed event of each variable to invoke the method. In this way, after changing a filter value, when leaving the field, the corresponding event will be triggered, which is expected to refresh the content of the grid. But what happens when the refresh command is invoked within a client-side event? In this architecture, since the objective is to have the page loaded as few times as possible, the data cache is prioritized. That is to say, we always try to retrieve the information previously saved. That is, depending on the caching configuration, it's decided whether or not to go to retrieve data from the server. When it's decided to go to the server, if there are no changes in the server data, nothing is returned to the client. Otherwise, the refresh and load events are executed, if there's a grid not based on an SDT, as in our case, and the fixed and variable parts of the panel are updated, as expected. We'll execute the panel to run everything we've just seen. With empty filters, all the attractions are shown. For each attraction, the total number of trips, calculated in the load event that updated the grid information, is correctly displayed. In addition, the overall total number of trips that is in the fixed part is shown correctly, since it was calculated in the refresh event and was executed before the fixed part was drawn. If we now choose the attractions of the country France, and choose to see the attractions starting with the letter H to the letter N, the value of the filters included in the grid conditions works correctly. Also, the invoked refresh commands caused the refresh and load events to be triggered, so the information was correctly updated when retrieved from the server. And we only see the attractions of France with the name in the chosen range. The following videos will discuss other aspects of the design and implementation of panel objects.